So let's talk about refraction. Refraction is just the special name for what happens to light when it goes from one medium into another. So let's talk first about transmission of light. There's some terms you need to know. Optical transmissivity, very fancy sounding word, is the ability of a material to allow light to pass through it. For example, we say that a material is transparent when it allows light to pass through without dispersion or distortion. You can see straight through the glass in front of this teddy bear. It's transparent. We say that something is translucent when it allows light to pass through, but the rays will be dispersed a bit. So here is the same teddy bear behind something that's translucent. The light can come through, but just like a diffuse reflection, the light rays are being scattered a little bit. They're being dispersed by the medium. And finally, opaque. Opaque materials do not allow light to pass through at all. Here's the teddy bear, most of it hiding behind something opaque. Okay, so now let's talk about refraction proper. Refraction is the bending of light rays at the boundary or interface as the light rays go from one medium to another. If you look at this picture, the light rays coming from the bottle behind are bent so much by going through the glass and the liquid, I assume it's water in the glass, they're bent so much that you actually see an upside down, an inverted image of the bottle. It's completely flipped around. That's refraction. The light rays are bent as they travel through. To talk about this more formally, there is actually a very well-defined relationship between the angle of incidence and the angle of refraction and these two media. Remembering again, we always measure these against the normal, that perpendicular line at the interface where the incident ray hits the interface. That's the angle of incidence compared to the normal. That's the angle of refraction compared to the normal. Now, the direction and the amount of bending depends on something called the optical density of the two media. Now, it's nothing to do with physical density. It's not about mass and volume. It's about the optical properties, the optical density. I'm mostly just going to say density, but it's optical density I'm talking about. So here is the law of refraction. Well, really, the laws of refraction. The second part is the same as for the laws of reflection. The incident ray, the normal, and the refracted ray are all in the same plane. That's just saying when the light ray comes in one way, it's not going to bend out at a completely different direction. Now, here's the essence of it. Light rays bend towards the normal, like this, towards the normal, when they go into a more dense medium. More dense bend towards the normal. And conversely, light rays bend away from the normal when they go into a less dense medium. So if the light rays were going the other way, it would bend away from the normal. In fact, this is symmetric. The mathematical relationship between these two angles is such that it's actually very predictable what would happen at the other side of a block of glass. When the light ray comes in from air and gets into the glass, it's going to bend towards the normal because the glass is optically more dense. What happens when it gets to the other side, assuming these two sides of the block of glass are actually parallel? Well, in that case, this here is a Z, so this angle in here is the same as this angle up here. And then, because the two media are the same, still glass and air, it's going to bend away from the normal to the same angle here as it came in at over here.